Our today's topic is chemical reactions and equations. We'll discuss first question. Why should a magnesium ribbon be cleaned before burning in air? The solution to this question is we know magnesium is a reactive metal. On storage with time, it combines with oxygen in atmosphere to form a layer of magnesium oxide over it. As magnesium oxide layer is dark in color, magnesium ribbon accumulates a dark layer. Hence, metallic magnesium loses its shine and becomes dark. The ribbon coated with this oxide layer will not facilitate burning easily and we will not get desired results. Its initial identity will be changed. Now, if we want to burn a magnesium ribbon, it has to be cleaned with fine sandpaper or steel wool. This will remove all the oxide coating which has deposited on the ribbon. This thoroughly cleaned magnesium ribbon, which is free from oxide deposits, burns with dazzling bright flame. The chemical reaction is as follows. Magnesium ribbon. It burns in presence of oxygen from air and forms magnesium oxide, that is a white powder. That is a balanced chemical equation. The next question is write balanced equation for the following chemical reactions. First is hydrogen combines with chlorine, forms hydrogen chloride. Solution is word equation for this is H2 gas reacts with Cl2 gas and forms hydrogen chloride HCl gas. Now as we can see here on the left hand side we have two atoms of hydrogen and two atoms of chlorine, and on the right hand side we have one atom of hydrogen and one atom of chlorine. On multiplying HCl by 2 we get two atoms of hydrogen and two atoms of chlorine on right hand side as well. Hence number of atoms of hydrogen are 2 on either side and number of atoms of chlorine are 2 on either side. Hence it is a balanced chemical equation. The next equation is barium chloride reacts with aluminium sulfate and forms barium sulfate and aluminium chloride. Word equation for this is BaCl2 barium chloride reacts with Al2SO4 whole thrice aluminum sulfate. Product formed is BaSO4 barium sulfate and AlCl3 aluminum chloride. Here we can see we have two atoms of aluminum on left hand side and one atom of aluminum on right hand side. So to balance the number of atoms of aluminum, we write 2 with AlCl3. Hence atoms of aluminum are 2 on either side. Now further, on right hand side we have 6 atoms of chlorine into AlCl3, and on left hand side we have only 2 atoms of chlorine. So to balance the number of atoms of aluminum, we multiply it with 3. Then 3 BaCl2 we have 6 atoms of chlorine, and on right hand side into AlCl3 we have 6 atoms of chlorine. Chlorine atoms are also balanced. Now further we balance the number of barium atoms as well. On right hand side we have only one atom of barium in BsO4. On multiplying it with 3 we get 3 atoms of barium on right hand side, which is equal to 3 atoms of barium on left. We have balanced number of barium atoms as well. Now finally SO4 group, we are making the equal number of SO4 group. We have 3 SO4 group in BsO4, and on left hand side we have 3 SO4 group in aluminum sulfate Al2SO4 whole thrice. So we have all atoms balanced on either side. This is balanced chemical equation. The next chemical equation is sodium reacts with water, forms sodium hydroxide and hydrogen. The balanced chemical equation is first word equation. Na reacts with H2O, forms sodium hydroxide, that is NaOH, and H2, that is hydrogen. If we see the number of atoms of hydrogen on either side in the water molecule, there are two atoms of hydrogen in on right hand side, two atoms of hydrogen in hydrogen molecule, and one atom of hydrogen in NaOH molecule. So three atoms of hydrogen on right hand side, two atoms of hydrogen on left hand side. To make them equal, we multiply H2O with 2. It makes 4 atoms of hydrogen here, and we multiply NaOH with 2. So we have 4 atoms of hydrogen on either side. Here in water molecule 4 atoms of hydrogen, and here on right hand side 2 atoms of hydrogen in sodium hydroxide and 2 atoms of hydrogen in H2 molecule. Further, atoms of oxygen are 2 on either side, they are already balanced. And finally we can check the number of atoms of sodium. On right hand side we have 2 atoms of sodium, on left hand side we have only one. On multiplying it with 2 we get 2 atoms of sodium on left hand side as well. That is balanced chemical equation. Next question, question number 3. Write balanced chemical equation with state symbols for the following reactions. The first is solution solution of barium chloride and sodium sulfate in water react to give insoluble sodium react to give insoluble barium sulfate and the solution of sodium chloride. Solution. State symbols are the symbols which represent the physical state of the reactants and products. So we'll be writing those state symbols here in the chemical equations. Barium chloride BaCl2, its solution present in water, that is its aqueous solution, reacts with solution of sodium sulfate, that is Na2SO4 in water, that is its aqueous solution. These two react to form insoluble barium sulfate, that is barium sulfate BaSO4 remains in solid state, that is obtained in the form of PPT, precipitate, white PPT, and along with it solution of sodium chloride is obtained, is NaCl in water, its aqueous solution. Now to balance this chemical equation, we have to equal the number of sodium and chlorine atoms only. On left hand side we have 2 atoms of sodium and 2 atoms of chlorine. On right hand side we have 1 sodium 1 chlorine atom. On multiplying it with 2, number of atoms of sodium and chlorine are balanced on either side. Sodium hydroxide solution in water reacts with hydrochloric acid solution in water to produce sodium chloride solution in water. The solution is sodium hydroxide solution in water is NaOH aqueous, reacts with HCl hydrochloric acid solution in water, that is HCl aqueous, reacts to form sodium chloride solution, that is NaCl in water, that is aqueous, and water H2O is liquid. That is the reaction of sodium hydroxide with HCl to form salt NaCl and water. This is the reaction of acid and base to form salt and water, that is neutralization reaction.